Yeah, I'm happy to jump in. It's great because I'm right next door, and as we are very close to ZKM, we are also very interested into spatial audio. We are an art school, which means we don't have special audio programs or something like that. But students are very interested in that because from the basis, they are interested in combining things and putting audio, video, whatever together and be creative and express things and do good, interesting stuff. So I would start with some background about the motivation and some previous work, and then have a look on the technical design of do-it-yourself wavefield system, and then about the design of a hemispheric multi-channel setup where we can do some ambisonics, high-order ambisonics, VBAP or whatever, and then trying to put them together, have a look on some software for spatialization, which is more or less quite well known, and some conclusions and outlook. So what had been before? So we had something like a speaker herd. We called it like that. I think in 2007 we got quite a bunch of speakers, which is about 50. They were meant to be in some way high quality, which ended up to get some Genelec speakers, 8040s. And it was meant to have that in really different setups, like the normal standard ambisonic circle, but then really not normal architectures, like putting them into a line or into arrays and grids and stuff like that. Flexible programming was an issue. That means put different software on that the people also could do their own spatialization, or maybe not spatialization, more in the direction of diffusion, or maybe also into the direction of sound art. And conventional speaker architecture, I already mentioned that. We had one thing just out of those setups, which was something like this full sphere setup, which we did in several times. People could go in and the speakers really surrounded them from all sides. Then 2013, we set up with this 42 speakers Genelex wavefield setup, which was very interesting. Markus Neusterik here helped us a lot with this, gave software and all this stuff. And it was pretty impressive at that time. I mean, wavefield synthesis had already been out for quite a while, but it's all had been definitely a question of how to get hands on it, really play on it and see what it's possible. Later on, we combined that. Here you see from the back, Marco Kempf working on his piece. There's another image later on. And we got from IRCAM, one of their bars, linear wavefield arrays, which are used to be able to swap around and brings them in different locations. And we had the luck to have that here for quite a while. This was a great thing, but it was also in some way difficult because we had to move it from one side of the school into another side because they needed there the space, and again to another, and so on. You know how things are. The system is based on this active Ethernet fed speakers, PMX5, and great system. So the setup was something like here on the ground floor sketch. Maybe you can, of this area in the next door where Edwin van der Weide has right now his installation. So we had a setup with 8 circular speakers, and here the line array of the IRCAM, which was quite interesting also about the effects of what wavefield system or also Ring of 8 does in a very special reverberary hall. This brought then the motivation, because the bar went away, and we got back to a project where we tried to set up a wayfield system with our own hands. And the ideas were quite similar. We wanted to integrate different spatialization systems for audio and music creation. We wanted to extend these projection techniques, explore them, but also to combine those. This is all the time this idea of combining things, and I think this really meets very well also the student interests. Get experience of spatialization techniques, experience of spatialization techniques concerning the software and hardware features, and also concerning musical aspects, how to use those things and really put them into a piece, and getting something out, or get that thing out they find in it. One big thing which came out was the stabilization of the working environment, because all this setting up, breaking down, setting up, breaking down, combining together, again, that really turned out to be something hindering, which is normal, it's nothing new, but in the end, this works, is a big issue, and that was also a drive to set it up in an environment where we could really work on it, something like a studio. In the end, naturally, as we have restricted resources, to combine these resources and to put them together, and what we don't have, build it, and also really look if it's possible to build it in a very DIY, do-it-yourself way. So we thought to make a horizontal line as we had, and then something like an ambisonics grid as a hemispheric space. We have a standard classroom, 6 by 6 meters, no special acoustic treatment, also important, because that's a natural question. Okay, how you treat the space later, we have a look on it. We use available things, the 8040 active units, and the low-cost DIY system. We started like designing something like this, having these units in 8 speaker packages to swap them around, to handle them, and which went to a Google sketch, and to get some more detailed numbers, and very fast into boxes. This was done quite fast. And first we built 2 of them to test whether it's in some way working. And then very fast in, as you see, some spaces hidden, some special rooms, and have some tests. The boxes have a distance or provide a distance of 14 centimeters of the speakers, which gives something like maximum frequency for wavefield synthesis about 1200 hertz. And the cabinets of each speaker are separated, as you see here. And the speakers are a Visotone speaker, 8 ohms, and it's not a very good one. It's something like a mid-range, but good one. So we tried to be in a reasonable but safe way to get some proper results. So we set up the array, and then in the Klinggut in Hamburg, for example, with Marco Kemp's piece. And as an installation, again, you see some circular speakers here, and also at here the Next Generation Festival in ZKM, where he performed also his piece with the wavefield system here in front. But the speakers is only one part. The more difficult part are the amplifiers, and that was the DIY part, which really took much more time. We went to the 41 hertz side, where there is a 4-channel digital amp, very compact, in a decent power radiation or power production, and decided this one. But this also is quite a time back in 2013, so actually the site is down, and yeah, maybe it's definitely time to look for another device. All that combined into a rack, so 4 of these units, and oops, do I have it here? 4 of these units in one rack. We see all these cables coming out of it. This is not like the very neat audio over Ethernet or DANT or whatever, but we are getting rid of integrating all this into devices. I would definitely go now going for a new approach with the students I would go for the recommendation to go for the digital audio streaming, and because this plugging in, plugging out is quite time consuming. So we're getting 16 channels out of one of these units, 2 units high. All 3 units we built in one rack, and this then set up in our studio room. We have the Moto devices here, which is actually quite nice because they are old, but they work quite well, and you can get some at the moment quite for a good price from the eBay. In the back we have some other Motos which are driving the channel X, which will the layout show just in the next slides. So this is then the setup. We moved the speakers from top to the side so that the boxes can stand up on the wall. Yeah, as you see here already, the speakers for the spherical setup, and this is done in this space. As I said, it's about 6 meters wide and C20 meters height. Has a C20 meter height, so it's not a very small room. It's something like an extended classroom for presentations. So no special treatment here on the side. Windows, entrance is here, which is not in the cut drawing. Here we see the wavefield, or the small wavefield system. We set it up in circular rings because which have 16 speakers on the floor, on the head level, then 8 in the next ring and 4 in the next ring and 1 speaker in the top, which gives something like a quite nice resolution on the ear level height, and reducing then the resolution in the upper areas. Sure, we're getting holes in this thing, so something like a high order ambisonics is possible, but not in a very high order, but it's definitely worth to work with it. The whole thing is in some way compressed because we have different height. We try to keep the angles quite into the direction to having something like a equally spaced setup for the grid. But according to how to mount that, I mean, we have to mount that all on something like a grid on the ceiling. Then we have also some slight different changes in the angles. But as you see, So here the distance is 2.5 meters, around 2.6, and to the top speaker it's 2.2 meters. The speaker grid is with 29 channel-X and 2 subwoofers, and we have for that one Motu 24IO and Motu 2408, because that gives us also the digital output, which we can convert to AES to drive the subwoofers. Short look maybe, I got here a very nice, or if it's working, yes. So how that looks like. We did the CAD drawing because we also wanted to see how these speakers really are in the space related. So these speakers are really now placed in the CAD drawing with the distances and the degrees, the elevation, everything as in the space. And yeah. What software we are using? We mainly use their Max 6 and Max 7, and thanks to Markus, the IRCAM Spat, for the Wayfield system. He offered us a special object. Definitely also Spat for the hemispheric grid. There it's quite handy to use ambisonics, high order ambisonics, VBAP, diffusion approaches, and also binaural rendering. So it's a quite large library for these things. And but we definitely offer also other softwares, definitely zirconium from here, which is quite often used. Super Collider, WFS Collider, Reaper, as really also very fancy approaches, or very unconventional approaches, just to pipe audio to different speakers. We can run the WFS and the ambisonics from one instance of Max. This might get problems on a CPU in terms of CPU resources. Definitely it's possible to use 2 instances, for example, of Max, or one instance Super Collider, WFS Collider and Max or something else. Definitely also combining with Reaper all these things and piping on one CPU together with Soundflower, with Jack, depending on the needs, or piping them directly to the audio devices. Also, we can use Dante for using different machines, combining them and sending them the audio to one central audio distributor. Yeah. But right now I think we only did for the WFS and the hemispheric setup to combination a one machine approach, so we get less problems of synchronization or delay issues. Reaper turned out to be in some ways the most neat and handy digital audio workstation environment for time-based composition, because for multi-channel approaches, because it's very, it has a very clear approach how to get the channels out of the time-based environment. Here, look to the environment of SPAT. We have here the hemispheric setup, as you may know, and here the OPER for controlling the sources and actually the host software, and on that side the audio processing. Quite similar here for the Wayfield array, here the loudspeaker arrays and the sources, and again here a SPAT viewer for the control of the system, and the actually object here is a WFS from IRCAM, and you see here quite this output where the focused sources will be built for one channel. As you may see, we only have 40 speakers on one wall because the wall is not wide enough to have 48. So we chop off 4 speaker outputs at the end, which will reduce the size, but doesn't make too much harm. So what are the results and the conclusions? We have the combination of wavefield system and ambisonics with reasonable effort that was possible. We can combine these different audio projection techniques, and for immersion, or for the question of immersion, we have definitely ambisonics as one of these spherical projection techniques which project from all sides, from all loudspeakers, and give anyway immersive impression. But then with these focused sources, we can, of the wavefield system, we can project onto the audience, and we experience that quite nicely. And as you see, or as you heard in the talk of, in the presentation of the Icos-AEDA, this is a technique which really can give a totally different impression of something like an ambisonic setup. So this is really interesting, also for the students to deal with this, to use that. We have the setup of this boxes, the speaker cabinets. This was quite straightforward, especially here at our school with all the workshops which we can use, which made it very easy. The more complicated thing for our resources is definitely the electronic and electrical setup of a real proper high numbered multi-channel amp system. There we needed much more time, and we are not yet fully satisfied, and I think that has to be thought about, and maybe make another layout and things like this. So there, I think is a little bit, or there is really a thing to think about, and to think whether there's a collaboration with real technical oriented schools, maybe really put the things forward. What is the outlook? Very easy optimization, which is get rid of these clamps at the speakers and the amps, and replace them with connectors. We want to make acoustic measurements tests, synchronization, loudness, noise floor, spatialization, and all that things, and definitely integrate that. That is most view into musical pieces and audio pieces. Also, software extensions, variations, maybe, which can be thought of, and extend the WFS into also different architectures, and try out something like a corner setup, maybe U setup, maybe displaced in the space. I think that could be interesting thing. A perspective here, also from Marcus from the MPEC, a very nice setup with very dense spacing, but Marcus will, I think, talk later about that much more, maybe. And it looks fantastic. I have to say thanks to Florence Schwarz. He did a lot of work on the amps, on the speaker grid, photos, tests. For Markus Kempf, for the housings, for the amps, photos, tests, and he did a good piece. Doi Kim for the drawings, Shashank Aswatanarayana for the quiz, the tests, And Richard Brunner, our electronic workshop head, aims test support, and definitely for Markus here, who initiated quite a lot of this, and his overall support. Thanks a lot.